The 7th video on simultaneous equations links up the previous video to standard techniques. So the first 6 videos looked at what is a straight line, what's a formula for a straight line, and how do we find the intercepts of two straight lines. And clearly this problem is often referred to as simultaneous equations. We gave a simple intuitive method for solving sets of two linear simultaneous equations. What we want to do now is move towards the more formal methods that students tend to use in schools, and we're going to show that these formal methods are in fact identical to the intuitive solution shown in the previous videos in this series. So what's the general principle when we're solving simultaneous equations? First thing you've got to do is to make something in each equation the same. As soon as you make something the same, then what's left has also got to be the same, and that way you can remove variables. So what was the background or the intuitive methods? We'll give some background on that. Here's an example. We had 0 equals 2x minus 4y minus 1, 0 equals 2 plus x minus 4y. So the first thing we said you had to do was put one variable on its own on the left and scale to make sure the coefficients are the same. Now in this particular case I'm going to choose the y, because you can see in both cases they've already got the same magnitude of coefficient, is minus 4. If I put those on the left hand side, they will both become plus 4. So there we are, we get 4y equals 2x minus 1, 4y equals 2 plus x. So the key thing is in both equations we have something that is the same. They both have a 4y. What do we do next? Given the left hand side is the same, then the right hand side must be the same. They've both got 4y, and therefore what's left, which here is 2x minus 1 and 2 plus x, they must also be the same. So we end up with this. 2 plus x equals 2x minus 1, and it should be straightforward to show that that gives you 3 equals x. Now once you've solved for x, you can put this value back into one of these equations to solve for y. So that's what we're going to do. You'll see we've said x equals 3, and we've taken the top equation here, 4y equals 2x minus 1, that's that one here, and we plug in the value for x, and we get 4y equals 6 minus 1, or 4y equals 5, or y equals 1.25. Now, you should always do a check before you finish, so put this value for y and this value for x into the other equation and check that it works. So that's what we're doing here. You see we've got x equals 3, y equals 1.25, there's the other equation. We put in the values and we get 5 equals 2 plus 3, which matches, and therefore we're confident that that's the solution. So this is the method we used in the previous video. Now, when you're in school, they tend to give you what I would probably call a shortcut method. So what's the difference? Well, strictly speaking, it's not necessary to move a variable to one side of the equation before you start. You'll notice we chose a variable, made the coefficient the same, and moved it to one side of the equation to get it out of the way. Now an equivalent process is to make the coefficient of one of the variables the same, and you'll see that's the same process, and then subtract the two equations one from the other. Now that might look very different to you, but what we're going to show you is in fact this is an identical procedure to the one we've already been using. So here's an example. We've got 0 equals 2x minus 4y minus 1, 0 equals 2 plus x minus 4y, and you will notice this is the same example as on the previous slide. So the first step is to make the coefficient of one of the variables the same in both equations, and in this particular case you can see we've got a minus 4y in both, and therefore this is already done. The next step is to subtract one equation from the other. So you'll see I've given them labels. I've said the top one's equation A and the bottom one is equation B. So I'm going to subtract equation B from equation A. Now because they've both got a minus 4y, these will disappear when you subtract because they're the same magnitude. So when I do a minus b, what I get left with is 2x minus 1, that's from the top equation, minus 2 plus x, that's from the bottom equation. And obviously, having got here, you can solve that and show that x equals 3. Now, what did we do on the previous video? What you'll notice is on the previous video, we ended up with this equation. By setting two sides to be equal, we ended up with 2 plus x equals 2x minus 1. But if you compare this with what we've got here, you should be able to see they are in fact the same equation. If I take this 2 plus x, which has got a minus sign on it, and move it to that side of the equation, you will see you've got an identical equality. Okay? And so in fact, the two methods are equivalent. Equivalent ways of getting to the same result. So the subtraction method, where one first sets the coefficients of a given variable to be equal and then subtract one equation from another, is in effect the same as setting the two equations to have an equal left-hand side. You will end up with the same problem. We'll do several examples to demonstrate that these two methods are in fact the same. So here you can see we've split the screen into two, and we'll use method 1 on the left hand side and method 2 on the right hand side and see what happens. So remember, the first step in both methods was to match the coefficients of one of the variables. Now in this particular case, I've decided to match the coefficients of the x. So in order to do that, I'm going to have to multiply this equation by 3 and this equation by 2, and then they'll both end up with a 6x. So let's do that. And so you see the top equation becomes 6x equals 12y minus 3, and the next equation 6x equals 4 minus 2y. Now this is the same in both methods. So we're happy so far, both methods are identical. Right, next, for the original method, we said if the left-hand side is the same, which you can see it is here, then I can equate the other sides. So I can equate the 12y minus 3 and the 4 minus 2y. So we'll do that. There you go. 12y minus 3 equals 4 minus 2y. With the method you get taught in schools and in textbooks, we said subtract one equation from the other equation. Now, if I subtract 6x from 6x, clearly they will disappear and I will get 0. So I've then got to subtract 4 minus 2y from 12y minus 3. And so this is what I get. 0 equals 12 minus y minus 3, that's the top, minus 4 minus 2y, that's the bottom. Now, look at these two equations. And what do you notice? They are in fact the same. I can easily take this 4 minus 2y, which has got a minus sign, put it on that side, and you see both these sides are saying the same thing. And so, in fact, both methods work the same way. Here's a different example. So we're going to use the two different methods to solve these equations here. So the first thing, I'm going to choose to match the coefficients of z. Now in order to do that, I need to multiply this bottom equation by 2, and then both equations will have a 4z. Please note that you'll see the equations are the same in both cases. Now, when I multiply by 2, you'll see I get 0 equals 4z minus 8 minus 2w, and 0 equals 40 plus 4z minus 14w. So what do you see? I've got a 4z here, and I've got a 4z here. And as before, it's the same step in both methods, so I've just put the right-hand side up ready. What's the next thing to do? Well, with the original method, we said move the z's to one side to make it clear what's going on. So let's do that. You'll see I get 4z equals 8 plus 2w, that's from this equation, and 4z equals 14w minus 40, that's from this equation. What do I do next? I say, well, because they've both got 4z here and they're the same, then these two bits that are left must also be the same. So I equate the two equal parts and I get 8 plus 2w equals 14w minus 40. Now, let's look at the subtraction method. In the subtraction method, we subtract, for example, the lower equation here from the upper equation here. And we note that because they've both got a 4z, they will disappear. So let's do the subtraction. And you see we get minus 8 minus 2w, that's from this top bit here, minus 40 minus 14w, that's those bits here. And what I want you to do is to compare these two equations you've got at the bottom. And as before, you will see they are in fact the same. Okay? So both methods have given you the same result. Okay, let's try this problem here then. So solve by equation subtraction. I've got x equals 10y minus 17, 4x equals 8 plus 2y. So what technique do I do? The first thing is to make one of the coefficients the same. So I'm going to do that by multiplying the top equation by 4 to give myself a 4x. So I get 4x equals 40y minus 68, and the equation below is the same, 4x equals 8 plus 2y. Okay? Now, if I do equation subtraction, I now subtract the lower equation from the upper equation, and you'll see 4x minus 4x gives me 0, 40y minus 2y gives me 38y, and minus 68 minus 8 gives me minus 76, and clearly that gives me y equals 2. Now I can substitute that into one of the other equations in order to solve for x. So for example, if I use the top equation first, then putting y equals 2 into that, I get x equals 20 minus 17, which equals 3. And then I use a check by putting both values into this bottom equation. So x equals 3, 4x equals 12, equals 8 plus 4. So it works. So I'm happy. Okay, what about this particular problem here? Now I need to make a slight adjustment before we start. That shouldn't be 3, that should be minus 5. Okay, so again we'll go through the same process. What we want to do is make one of the variables the same. Now I'm going to choose to make the w's the same, and I can do that by multiplying this one by 2. So I get 0 equals 16t minus 4 plus 4w, and the equation below, I'm going to put it the other way around because it makes life easier. I'm going to get 0 equals 4w plus 5 minus t. Okay, so now what you can see is both equations contain a 4w. So if I now subtract the lower equation from the upper equation, what am I going to get? Oh, I forgot to multiply something here. I apologise, there should have been a 2 in front of that t there. So let's put that 2 in there. There we go. Okay, so now let's do the subtraction, and what do we get? We get 0 equals, so 16t minus minus 2t gives me 18t, and minus 4 minus 5 gives me minus 9, and therefore t equals 0.5. Right, the next step is to put this value into the equations and solve for w. So I'm going to start by using equation 1. So if I use equation 1, I get 0 equals 8t, which is 4, minus 2 plus 2w, and this tells me that w equals minus 1. And then I put both these values into the second equation. So 4w is minus 4, 2t is 1, and I've got a minus 5 there, and it checks. So in summary, we've demonstrated a general approach to solving simultaneous equations of straight lines where there's 2 of them. The first step, set the coefficient of one variable to be the same by scaling, that's multiplying each equation as required. Step 2, subtract the two equations so that that particular variable disappears. Step 3, solve for the remaining variable. Step 4, once you know one variable, you can substitute this into an original equation to find the other, and then use the final equation to do a check to make sure you haven't made a silly mistake.